Hi, my name is Morgan King. I am currently enrolled in ECE535. This is my experimental project demonstration for the AC hand crank generator. My AC hand crank generator displays the fundamentals of magnetism via Faraday's law of induction. On the left side, this is an equation directly from the notes that states the same ideology of the generator, of how it works. On the right-hand side, this is a diagram that I created just showing my crank handle, which would be attached to a threaded shaft. I have my rotor with my magnets, and then I have my stator with my wire coils. I decided for all my wire coils to be in series versus in parallel. By putting them in series, you increase the voltage but decrease the amperage. And then I have my wooden base. I decided to use a full bridge rectifier to convert my power from AC of the generator to DC for the LED to run. Inside, I got my wooden base, L brackets, threaded shaft, nuts, washers, and a makeshift handle. On the right hand side, I've used some pulleys from my exercise machine that had bearings in the center. On the left side, you can see that the rotor, I have 4 magnets that are spaced equally apart, each in alternating configurations of north-south, north-south. This side, I actually glued the bearing so it would rotate more freely with the threaded shaft. And then on the right side, I have my stator, which has 8 coils with 200 turns of wire, and then a bunch of different hardware that I used. The stator would be intended to stay stationary, while the rotor will turn in time with the threaded shaft. On the left-hand side, I have my testing set up there. On the right-hand side, I show the spacing where I tried to minimize the gap between the magnets and wire coils to maximize the induced voltage. I currently have those spaced using a combination of nylon and metal washers. I have nuts on each side of the pulleys that hold them tightly to the threaded shaft for rotation. As I stated before, my stator is fixed in place by using the bearing, but also further using fishing line to further prevent rotation. On the left-hand side here, you can see I have a demonstration showing that my circuit does work correctly. I just plugged it up to my laptop as an external power source. I've got my full bridge rectifier there, which is just 4 diodes put together in a specific configuration to chop the AC power to resemble more like DC. I have 9 very haphazardly placed capacitors. I have 9 which were 100 microfarad in parallel, which would essentially equal 900 microfarad all put together, and then I have my LED. As you can see here, when I'm just cranking it by hand, I'm able to get about 0.15 volts. This is capacitor is completely discharged. And then as I'm turning the handle as fast as I can and letting go, I'm able to get up to about like 0.26 volts. To turn the threaded shaft quicker, I used a drill here. I'm able, as I turn using the drill, I'm able to get up to about 0.7 volts, which is ultimately not enough to light the LED. The forward voltage on the LED for a red LED, which happens to be the lowest, is about approximately 1.7 volts, 1.7 to 2.0 volts, with 2.0 being it fully lit. So unfortunately, I was not able to generate enough power with the current design iteration that I'm at to light the LED. So what went wrong? First off, materials were not available locally. I had to order pretty much everything except for the hardware and the wooden board. I live in a rural area, a rural part of North Carolina. Magnets especially were a really big issue going throughout this process. I ordered 3 different sets of magnets over like the course of 2 weeks working on the project, and none of the magnets were really what I needed. I had some difficulty with assembly, using the hot glue. I think that with the magnets made it a little bit temperamental at times. And then just for the scope of project, for the time allotted, given the current area I live, I think the combination of that is kind of what led to this project not working correctly. And that is my AC hand generator project. Thank you for watching.